In this example, I will show you how to add a new place into the existing scope. The scope I will work with is Urban Atlas Cities, and it's a scope where you will generate the zonal statistics for certain classes from the Urban Atlas for given cities. First, we need to upload the data layers. That's done in the data layers menu choice. Here you have the part of the upload the layer, and here we choose the file that you want to upload. I've decided to try with one of the Czech cities. I've already prepared a few others so that there is some meaningful comparison. So the boundaries were uploaded, and now I will also upload the Urban Atlas, which is be shown and will be source of the data for the zonal analysis. Now both layers were uploaded to the system. First, I will start with mapping of the boundaries. So now we will map the boundaries. Boundaries is analytical units layer in this case. It belongs to the scope demo urban atlas cities because that's the one where we want to add the place. And we don't yet have the place, so we need to create a new one. In this case, it's a most. So we will add a new place. The tool where we can select the information about the place will be open. It will take some time to load the map that we use to show the bounding box. We want the place to be active. We want it to be in the right scope, in this case urban atlas cities. And we want to figure out the right bounding box. In this case, the most area is approximately here. So by clicking Shift left top and Shift bottom right, we will create the bounding box, and then we save the place. So now the place exists correctly in the system. We can close it, and we can move to mapping. In this case, there is just one level of analytical units. It's possible to create hierarchies of the analytical units, where you have less and more detailed areas. But in this specific case, we are focusing on large urban areas, so on a lower level. Every analytical units layer have to have a feature identifier, which needs to be unique information. That's all that's needed. And it can have a name, which will be used in the UI for the user. In this case, cities is meaningful name for us. Feature name. Save. Now we wait until the mapping and creation of the metadata is processed. At the moment, the metadata for the boundaries should be available. Next, we are going to map the urban atlas. It's possible to display this layer using standard urban atlas style, and later on we will also prepare zonal analysis based on this urban layer. So in this case, it's a vector layer. Layer template is UA length cover in this case. As we can see, it has some basic information such as style and attribute sets that are useful and available for the analysis. Scope is again the same one, urban atlas cities. Place is the one we created before, so most. And all the data that we work with at the moment are from the period 2012. The vector layer again have to have the feature identifier. And as we would like to use the urban atlas code for further analysis, we also need to map this. For the prepared analysis to work correctly, so that we can only run it and don't have to create it again, we should use the length cover code as seen here. and again 2012. By clicking on Save, again the metadata are prepared. It takes a while, but then the layer will be available as a source for the analysis. So now the layer was prepared and we can move further. In order to show meaningful information in the UI, we want to provide a user with at least certain attributes calculated for the area, like the area that contains given class. In order to do this, we can go to the analysis. Here we already have prepared Urban Fabric analysis, which is the analysis that takes as a source information the land cover code on the UI land cover layer that we just right now mapped, and store the filtered information bases stored by the land cover code in the result attribute set. In order to run this analysis for the new place, we just add a run. Demo Urban Atlas Cities, Places, Most, 2012, and Lua. Now we started the zone analysis. It will take a while. It might take like 5 to 10 minutes to process fully. Now we can see that the analysis was successfully finished. If it was failed, there would be failed with the error shown when we overlay it. And now the last thing that remains is to move to the data exploration and see that it's really there. We can see Demo Urban Atlas Cities. Here we see one of the data views that we created before. It's just the way that we get there unless there are some information. Now at the moment, we can see that we have the place Most, which is one of the areas that we are actually interested in. In the layers, we can see the area outlines. Now we can see for all the 5 areas that are interested, this one is Most. We can select and show the Urban Atlas, as you see, with the legend that's available here. If you want to, it's in this area. I know that there are actually mountains around here, so that's one of the places where it may make sense for you to see the area using the standard elevation. And as the standard model is relatively coarse, it might be better for you to let the elevation grow up a bit so that you can really see the differences over there. On top of this information, we also prepared the statistical information. This is what we did using the zonal analysis. And we can show it using the new polar chart, where we can select all the attributes. They will be shown at the moment in the chart on the right for all the cities that are part of this scope. It doesn't really make sense to just show them directly, so we will normalize it per area to get the percentage of the area that's fulfilled by a certain class. At the moment, we can see the chart that contains all the 5 cities. But as you can see, it's already a bit confusing. There is too many things. It's possible to choose, for example, just selection of the two cities. And then filter the information clicking on only selected. Now we see the information for the Most and the information for the Plzeň. That's it.